Gentlemen, we're here today to have a conversation about this little amplifier. This little 10 pill I built for my friend Richard. Oh, it's been a couple years now. And when we were talking on the phone, me and Richard were talking about how, he needed to have this thing really quiet. And so I put it all together for him. It's really cool looking pretty on the inside. I mean, it's a neat looking amp. And I sent it to him, and it ran really good for about a year and a half. And then he popped a pill in it. And he sent it to me, and I got to talking with him. And come to find out, he was using this thing kind of maybe not within the 40 channels, let's say. So I set the tune up on this amplifier and I told him, oh man, I wouldn't have done that because it works really good on, in the 40 channels. And I didn't realize that he was using it way away from the 40 channels. Like way, way, way away from the 40 channels. And I think that's what might have led to our first blow up. So I put a new pill in it and I changed the tune on it to be a little bit more appropriate for that frequency that he was wanting to use it on. Well, he took what I had to say sincerely, which I really respect that. And he went back to using it just on 11 meters and went out and bought himself an amplifier that was a little bit more specific towards the frequency that he was wanting to operate on, that and a bunch of others. Let's see, what do we got in here? Oh yeah, same before, lost a pill. Okay, no big deal. We'll get in there and we'll change that real fast. It's not that hard. Anyhow, so he went to using it. Look at this, isn't this pretty? This thing is like a work of art on the inside. So it had the tune for the higher frequency in it, but then he ended up using it back in the 11 meter band. And it ran for about another 3, 4, maybe 5 months, I don't know, a few months. And it let another pill go. Well, that's when it made its way to my friend 757. Now, I don't know if you guys have heard of this guy or not. He does some pretty good work. He doesn't need the money, would be the best way to put it. So he builds this for the fun of it and to keep himself occupied. And he is able to, get stuff in and out pretty quick. Well, me and him share a lot of the same friends in common, and that's just radio. So this went over to him, and he replaced a pill in it, and he did not change the tune in it because I called him and I said, hey man, the last I heard he was using this thing on X frequency. Let's not change the tune on it. I set it up specifically for that. So all he did was he went in and he changed the pill, the one transistor that popped, which I'm grateful for him doing, because then homie got his amplifier back. Well, then I called and I talked with my friend Richard, and I said, hey man, he does good work. I'm sorry, I'm on an extreme sense of overload on an everyday kind of thing. Like every day of the week, I got too much going on for my own good. So that's when the knowledge started to come out of him that maybe we had bought a new amplifier and we're using it for the other band, and this one needs to be retuned back for the other one. I said, well, okay, if it ends up popping a pill on you, call me and we'll do some different things. Well, one of the things that caught my eye the first time it was here was, let's see, how do I show you this? Let me zoom in here, hold on. I'm trying to do everything with only 2 hands here. If we look really close in through here, and we're looking at the phenolic board, you'll see that it's discolored around the transistors. And that's something that's indicative of something getting really hot. Now, I know this guy and I know the way he runs his stuff. He is incredibly sensitive to drive, operation procedure. He just, let's face it, he's a good dude. He's a smart radio operator, and he's really attentive to what he's doing with his equipment. So I'm just saying that my idea that I had was that maybe what we should do is when we get it back here, this go around, that maybe we not be so worried about fan noise. I mean, these are just my thoughts. I thought that we were going to be loafing this thing along, in which he was basically loafing this thing along. But when I can see that much of a heating strip right, and the disadvantage to having all the transistors in a line like this, let me find a piece of heat sink. Here we go. Here, we'll grab this one out of this X-Force amplifier that I pulled out many years ago. The heatsink that's actually in this amplifier is, well, it runs from hole to hole. This is, the heatsink that's in here is this much wider, okay? X-Force had this in a 10-pil base unit. And this is some ass piece of scrap. And he had 10 transistors mounted on this piece of scrap heatsink. The reason I have it out is we'll say that this nut here, this is a theory. This nut represents how much surface contact the transistor has with the heatsink. When you line them all up in a row, so transistor, 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 all of your heat energy input, because that's what heat is, it's energy. The heat energy is getting supersaturated down the middle of the transistor. So you'll have one, maybe two fins that the the transistor is actually sitting over the top of. In this case, it would be 3. So these 3 heat fins are going to get a majority of the energy input for heat dissipation. Now, you and I all know we're surrounded by a bunch of very smart people in this business, that copper and aluminum are very good conductors in all shapes and all forms of energy. Either it be aluminum, you know, for electricity, and a copper also for electricity and heat. When it comes to heat, they share some different principles, right? So aluminum is a very good transfer media to air, meaning it's very good at taking heat energy and radiating it, transmitting it, coupling it, pairing it to air. Okay. Copper is very good at absorbing heat and then distributing heat. And then also it can be used as a good transfer media. It's not as efficient as being a transfer media for heat energy as aluminum. Aluminum wins out just barely over copper for the transfer of the heat energy. But copper is vastly superior to being able to spread the heat over a larger surface. So sinking, actually physically sucking up the heat energy and spreading it out over a larger footprint. So with this amplifier, because the heatsink runs from end of cabinet to the front of cabinet, which is still massively longer than what, I mean, we're talking the piece of heatsink that's in here over what this is here. The heatsink's a good 1.5 inches longer, and it's easily, here, let's see, easily double the thickness as this piece of aluminum. When I see heat getting transferred back from the heatsink to the phenolic and causing this discolorization, that's telling me 2 things. Maybe these 10 transistors would have been better off if we did like a row of 5 and a row of 5, but actually it'd have to be like a row of 6 and a row of 4 going this way. And that way we can utilize more of the heatsink bed to transfer more energy directly to the fins versus just these 3 fins down the middle. Or we could put a spreader in here. But the discolorization, the level that I see it at in here, tells me that I do not have enough airflow going through this cabinet. Just don't. So that's when we go over here and we look at these Sun-On fans that are in here. These are great little fans. I personally feel, I don't think that there's enough air transfer to the cabinet. And my phone has not stopped ringing all day. Phone's over there ringing right now. That's the reason I said that. You guys can't tell it because you can't hear it. I got my ringer off. So what we're going to do is we're going to replace the transistor and we're going to double down on our airflow. So we're going to significantly increase our airflow through the cabinet, and hopefully, and we're going to change the tune. We're going to change the tune to where this amplifier was originally designed to operate. If I was to build an amplifier for another band, everything changes. The output capacitance on the output transformers I would change, the input capacitance, the input capacitance on the input transformers, the output capacitance on the output transformers, the input-output tune, all of those kinds of things. Where with this situation, all I did was I just changed the capacitance to bring its output tune resonance a little bit closer to the frequency you wanted to operate on. I think that that might be a double negative for us. And since he's no longer using it at that frequency, okay, let's embrace that. And yeah, let's embrace that. We're going to change the tune on the box a little bit. Change the cap. I think we're going to double the amount of volume of air. We're going to pull off these little grills. We might go to some BBI water jet fan guards, which allow even more air to get inside. And let's maximize our amount of airflow and see if we can overcome this heating issue. And the other thing that we have to think about is which transistor popped. If it's one of these transistors up here up front, that's a tune issue usually. But when we start seeing them to blow up back here in the back, like these back four, what that's telling me is the amount of air that's going through the cabinet has already reached its maximum amount of saturation of heat level by the time it's getting to this end of the cabinet. I don't know how well this transfers on video. Let's see if I can get the ISO gain just right. Our discolorization starts about here and it gets darker as we're going to the back. That tells me that we have exceeded the amount of air moving through the cabinet, its ability to be able to transfer heat away from the components. So these transistors are sitting up here just as happy as, 16-year-old getting to play with girlfriends, nanas. Where these here in the back, man, they're stripped down in their underwear and they're digging a hole in the ground, working out in 105-degree heat, and they're working their asses off, and they're not able to get rid of the heat because the air that's flowing by them has already been preheated by these first six. Does that make sense? Well, in this particular application, this transistor here popped, which is 1, 2, 3, 4, 5, 6. It's the 7th transistor back. Just saying. Now, if I'm not mistaken, when this was here last time, it was the 6th transistor, or it was the 8th transistor. So the language that the amplifier is sharing with us and telling us is saying, hey, I don't have enough air, and 2, we're getting oversaturated with heat by the time it's leaving the back of the cabinet, and 3, this amp's used exclusively on sideband. Well, you're at 100%, almost 100% duty cycle on sideband, right? 100% boop, 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 and pulsed modulation, right? The transistor's got to work a lot harder on sideband, current consumption-wise, than AM. And, this amplifier will do several thousand watts, right? Even if he's backed it down to, I can't remember what Richard told me, and I'm sure he'll tell me when we get on the phone. Everybody does this. I do the video, I talk about their amps, and then they call me up. So I didn't run it like that, blah, blah. It's beyond the point. I don't care. Even if he's backed it down to where he's only getting, let's say 12, 1500 out of the amplifier, That's a lot of heat saturation going on with the heatsink. And a lot of guys on sideband, they're a little bit longer winded than most of us AM guys, come to find out. Just passively making this observation, not saying that's the exact situation that's going on here, because I'm not saying that. But I have listened to some guys on 80 meters, on 40 meters, on 20 meters, on 10 meters, on channel 38, channel 45, where they will start talking, and they will talk nonstop for 15 minutes. I'm not saying that's what this has happened with this guy. I don't believe that's how he operates. But if they don't have massive amount of air moving on their part, in hindsight, I should have probably done a different cabinet, right? In theory. Had, instead of everything being down the middle, it'd go this way. The problem is nobody ever wants to talk about things. Like, I'm admitting, okay, I should have used a different cabinet. Okay? We get that. At the time, I was lucky to be able to even get this cabinet. When I built this, the company that we get our cabinets from, ICA Manufacturing, was moving their machine shop. Now, I like Richard, I like him a lot, and we were on a timeline, and I built this within that timeline that I was given. And it wouldn't have mattered, because it took, even after I got this amplifier built, it took them another 6 months to get their machine shop fully functional. So I had to take what was in the market at the time for cabinet, board, and heatsink. There was an aluminum shortage going on. There was a heatsink shortage at the time. There was a cabinet shortage at the time. The only thing there wasn't a shortage on was all the miscellaneous components. Okay, and I thought, okay, this will work great for him, not realizing that we were going to have to build like a super. So I was able to get a cabinet, which I felt lucky that I was able to get at the time, because there were no cabinets in the market for the most part. And the board, there was a reason that I had to build this whole elevated platform to put the relay and the output tank, or the output tuning coil, and the combiners and the splitters and all this stuff up on this board, is because this is all we could get at the time. That makes sense? So 6 dozen, 1/2 ways the other. Fast forward several years later, here we are talking about it, right? You, me, everybody that's watching this video. I, today, would not use this cabinet. I would not. I would use probably a 16-pill enclosure. Spread it out. These are 5 2-pill sections that I put together here, so I could spread them out. Have a 2-pill, skip a heatsink, have a 2-pill, skip a heatsink. Have a 2-pill section, skip a transistor, have another 2-pill, and spread everything out. Split it up against multiple pieces of heatsink, so we don't have quite the heat density going on. This is like a Lambo, right? Little Lamborghini does 1,000,000 miles an hour. Now, is that really the car that you want to go and take on the 4,000-mile road trip and run at 190 miles an hour the entire time? No. This is a badass little box. In hindsight, I wish I wouldn't have had to use this cabinet. I wish it would not have been worked out like this, but this is what we got. I still built him a wonderful amplifier. There's a lot of different factors that go into play. The frequency it was getting used in, blah, 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 right? So put all the cards on the table. Let's go in here, let's change the transistor, let's change our tune, let's put bigger fans on it, let's increase the airflow through the cabinet, which will these fans are great, but we can double down on this and almost double the amount of air movement through the cabinet. And with us changing the tune, now the transistors aren't creating RF and having to fight it to go out. It'll be more mono of a frequency that'll allow us to capitalize on efficiency. Will increase the efficiency of the circuitry around the transistor, which will make them run cooler. Okay, enough talk. Let's do. Okay, so transistor replaced. Let's see where we at. This is a let's see, 1,000 in peak, 1,000 in average, 5-watt slug in reverse. So we got the derail 955. Hello, 1, 2. 80 watts of drive. Hello, audio. Hello, audio, 1, 2. Okay, our input tune is really high. So we're going to use both the striker and the bird meter, this meter and this meter. Hello, showing a 1.5 here, and then up on the bird, hello, audio. 1 watt worth of input reflag. So now if we go, see, band, we jump up to 28 megahertz. Hello, audio. A little bit worse. So we'll go down to 27,855. Hello, audio, 1, 2. A little better. 2740. Hello, audio. And 26,955. Hello, 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 hello. God, where is this thing tuned for? All right. Band. Go right to the middle of the band here. Hello, 1, 2, 1, 2, 1, 2. Okay, well, needless to say, we're going to change all this around. Let's go back over here for a hot minute. Hello, 1, 2, 1, 2, 1, 2. Let's play. All right, all right, all right. All right, all right, all right. All right. So, we're back. Everything's the same. Same units of measure, same everything. Hello, 1, 2, 1, 2. Yeah, it's gonna perform better. Let's go up here. Let's look at the bird meter first. Hello, 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 hello. Let's look at the striker. Hello, 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 hello. It's flat. Hello, hello. Now I want to point this out to the owner. If you go and run it up in this frequency, I cannot help you. Hello, 1, 2. If you go and run it at this frequency, hello, 1, 2, I cannot help you. If you go and run it up here, hello, 1, 2. I cannot help you. This is channel 65. Hello, 1, 2. Now we're starting to come outside of the box's performance envelope. But if we stay right here, we'll say hello, 1, 2, 1, 2. We'll run this on down to channel 1. Hello, 1, 2, 1, 2. Or we run this to channel 40. Hello, 1, 2, 1, 2. We're within the design operations for this piece of equipment. Fact. So, just want to be really clear where we have it tuned for at the moment. I think I made that clear enough. Okay. So now, we've done all of our baseline testing at 12 volts. All right. Hello. Oh, wrong microphone. Hello, 1, 2. So we picked up 100 watts just by changing the tune. And I went ahead and, like I said, I had this tuned out for a little bit higher up in frequency response, right? Like above 40, we'll say. Well, he's gone off, like I said, and he's bought himself a different piece of equipment now. So let's turn the voltage up, and he's using that for the other frequencies. But this one, he wants to keep using it where he wanted to have it built for. So there's no confusion on where we're running the amp. Hello. It's disappearing off the scale. We'll go to 2x. So now when the needle goes all the way to the right, we're 2,000 watts. We're putting about 120 watts of drive into this. Hello. There's 18 and change with 120 watts of drive. Hello, 1, 2. Let's go up here real quick. Let's verify. Hello, 1, 2. 16 and some change. Hello. Yeah, we're almost to the 19 mark. All right, we'll shut this radio down. We're going to switch radios now. We're going to switch over to the 490. Please note, we still don't have the lid on it. 490 does almost, 160 watts, 180 watts, something like that. Amp off. Back to 1x multiplier. Hello, 490. Hello, 490. About 190 watts of drive. Go back up to 2x. We'll turn on the 10 pill. Hello. Hello, audio. Hello, audio. Hello, audio. Hello. Run on up there to 2 grand, no problem. Hello. Sitting there playing with the output tuning tube. Hello, audio, 1, 2. 2 grand, no problem at all. Okay, so our combiner ring is ice cold. Let's look at our transistor heat. 119, come on, refresh. 120, 124, 123, 122. So now we've loaded the heat sink full of heat. Let's go take a look for here. Well, universally the same amount of saturation on the heatsink. Okay, let's set this aside because obviously this is fixed. Sorry. Had you guys zoomed in that entire time. Combiner, as you guys can clearly see, is ice cold. No imbalances there. Nothing's overly hot here. Input splitter's cold, output combiner's cold, output tuning coil cold. Okay, let's set this here. Now to put a little bit more of an aggressive fan into play. Let me go over to that cabinet, pull those fans, we'll get going. Okay, peak kit on, amplifier on, striker on, 12 volts. Let's see, you guys can't see the voltmeter, sorry. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Hello, audio. Let's take this up to 2x. Hello, audio. Making 1200 watts peak. Let's turn our voltage up. Hello, audio. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2, audio. All right, now let's bang this with the striker. Now that we've doubled the volume of air going through the cabinet. All right. Hello. All right. Hello, audio. 1, 2, 1, 2. Put a lower sideband. Hello, audio, 1 2 1 2 1 2. Hello, audio, 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. Hello, audio, 1 2 1 2 1 2 1 2. Hello, audio, 1 2 1 2 1 2 1 2 audio, 1 2. Hello, 1 2 1 2 1 2 audio. Hello, audio, 1 2. 1,000+ bird on the average scale. Hello, audio, 1 2. Audio. Hello, audio. I don't want to say we're being abusive, but we got to put it to a test, right? We've got to run it through its paces. Wow. The hottest thing back here is this ground plug. Look at that. Huh. That's interesting. And it's well over 100 degrees. What is going on here? Now, I made this connector, I think. My heat shrink. What is going on inside of you? Well, it's crimped. Honestly, I want to reflow the solder back into this connector. That's getting way too hot. It's like some kind of fuse. That's interesting. Okay. Hello, 1 2 1 2 1 2 1 2 1 2. Hello, hello, hello. Hello, hello, 1 2 1 2 audio, testing, testing, testing. Hello, 1 2. So we got a little bit of heat rise, but nothing like what it was. I really wish there we go. Now you guys can kind of see what I'm looking at. So put something hot in perspective. Dang it. Here. Come on, camera, play. These people on YouTube want to watch and enjoy. That's how much heat rise we're seeing. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Hello, audio. So we're seeing about, nothing in comparison to my finger. We're seeing maybe a degree, if that. So I re-crimped it, resoldered it. I don't know. I know we're moving significantly more air through the heatsink. And remember that the vent is facing towards us, so It's really not that overly loud. It's really not. Well, we're going to give this a run. This ends up coming apart. We'll have to think about doing something else, but like I said in the beginning of the video, in the time and the era that this thing was put together, this is the best cabinet we could get at the time. We had no other options. And, I mean, we're talking months of us waiting, right? Just to get the cabinet. So when I got the cabinet, I was all excited. But changed the tune around, so now it's dead nuts on for 27 megahertz instead of trying to make it really broad. That'll probably help us out a ton. Twice the amount of airflow, new fans. I think you're good to go. Thoroughly tested the snot out of this. It's making well over 1,000 bird with no problem at all, and that's just with the radio drive. So we'll send it on. We'll see what happens. I'm going to wrap this up, gentlemen. I'm going to go on to another project. I've been kind of stuck on this one as a kind of on the shelf thing. I've had a ton of stuff going on in the background that I can't even really get into right now, but needless to say, some really cool shit's coming. I got a dual 4-1000 amp that I'm going to work on here probably tomorrow or the day after, but I got a couple other things I need to just I got to just get a couple little things out of the way. Do the 4-1000, and then we're going to start getting ourselves prepped. The BBI Bakerman Group break, 23rd annual over at Rooster Rock State Park. So shout out to Penta, XS, Siglent, Bird, Coaxial Dynamics. If you've ever learned anything from this channel, you might want to think about jumping and coming and helping us out over here on Patreon. I don't know if you guys have been paying attention to what's going on with YouTube lately, but it doesn't matter that you have 75 or 100,000 views per day. YouTube's ad revenue's gone to nothing, right? Just gone to nothing. I basically do these videos for free, and if it wasn't for the support of the Patreon group here, I don't know if I'd still be doing YouTube videos or not. So you might want to think about coming over and just showing a little bit of support. It's super cheap, stupid cheap. And you get access to a bunch of behind the scenes content and everything. You get access to everything I'm working on all the time. So just might want to think about coming and checking it out. Okay, on that note, I'm going to run. Got a ton of stuff I got to get ready to do, and this one just needed to get fixed immediately and get out the door. So on that note, gentlemen, I appreciate you all. I'm on to the next one. Big shout out to my Patreons, and absolutely thank you, every single one of you guys, for tuning in and following along. Boom diggity. On to the next one.